I am going to explain 8 as to 1 multiplexer. So multiplexer have multiple inputs and one output. In this case, there are 8 inputs and one output. There are 8 data input lines from I0 to I7 and 3 select lines S0, S1 and S2 and one output Y. The output Y depends on selection of select lines. When select lines are 0, 0, 0, then output Y will I0. When select lines are 0, 0, 1, then output Y will I1. Also, similarly, when select lines are 0, 1, 0, then output y is I2. When select lines are 0, 1, 1, then output I is equal to I3. And when select lines are 1, 0, 0, then output y is I4. When select lines are 1, 0, 1, then output y is equal to I5. When select lines are 1, 1, 0, then output will I6. And similarly for I7, when select lines are 1, 1, 1. So this is overall expression for y output, and this is truth table for 8 as to 1. I am going to explain 8 as to 1 multiplexer. So basically multiplexer have multiple inputs and one output. In this case there are 7 input lines I0 to I7 and 3 select lines S0, S1, S2 and one output Y. When select lines are 0, 0, 0, the output Y will be I0. When select lines are 0, 0, 1, then output will y is equal to I1. When select lines are 0, 1, 0, then output will I2. When select lines are 0, 1, 1, then output will I3. When select lines 1, 0, 0, then output will I4. Similarly, when select lines are 1, 0, 1, then output will I5. When select lines are 1, 1, 0, then output will I6. And when select lines are 1, 1, 1, then output will I7. So basically this is overall expression of output y. This is a truth table and expression of multiplexer 8 as to 1. Now we will come to Xilinx and create a new file which is named as mux 81821. After creating new file, we will add a new source in the file. Now give any name to the file and select VHDL module. In this case, I will give name as mux81a. Now select input data lines I and click on bus and 7 to 0. Now there are 3 select lines, so click on in and bus and 2 to 0. After that we need one output, that is y, so select out. Now the source get added and we need to write the architecture for our code. So this is a entity in which we have taken I, S and Y respectively, where I are data input lines, S are select lines and Y is output. Now after writing the code for entity, we are moving to architecture, in which we have to write the code for the multiplexer. So I am going to write the code for the multiplexer using when else. So Code for first input line is ready. I0 when s equal to 000, else then just copy paste the above lines for 8 times and change the expression as per the condition. Now here I1 when s equal to 001. Similarly for this expression is valid for I2, I3, I4, I5, I6 as per the selection of select lines. So this is writing using truth table for 8:1 multiplexer. After writing I6, just simply write I7 else I7 and give the semicolon. Now our code part is completed for architecture. Now check the syntax using implement design. So it will take few time for executing this code. So the syntax is correct and it is a verified code. So now just view RTL schematic. Click on RTL schematic. We will get pin diagram for 8:1 multiplexer. It taking time. So this is a pin diagram for the 8:1 multiplexer where there are 8 data input lines, 3 select lines and 1 output, that is Y. So this is a circuit diagram. When we click on pin diagram we will get such look. So there are 1 output Y and 8 data input lines and 3 select lines. Now we will just cut this and comes to the code. Then after that we will add another source for waveform. Just give any name. I will give it as test bench, test mux. Then click on waveform. Click on finish. So this is the waveforms. Now simply click on this. As per our requirements we will see the waveforms. The select signals will vary over time, cycling through 000 to 111. So the 8 input lines show different data values over time. The waveform Y changes based on the select signal. When S selects a particular input, for example, let's take 010 for D2, the output Y should match the waveform of D2. So this is the overall waveform, and we will check for each data input lines and select lines. So this is the overall 8:1 multiplexer presentation. Here we have executed the code in Xilinx. Firstly, we have checked the truth table for 8 to 1 multiplexer. Then we will go to Xilinx and execute our code, and then we will get circuit diagram as well as the waveforms for 8 to 1 multiplexer. So thank you.